Good morning, students. Our today's topic in the Pure Mathematics 3 in the class A levels is vectors. And in vectors, first we are going to read today is the line. So concentrate yourself. R is equal to A plus lambda B is the vector equation of a line that is parallel to vector B. That is parallel to vector B. And B is also called the direction vector, and which passes through a point A with position vector A. So A is the position vector and B is called the direction vector. So this is the vector equation of the line. So here are two questions, very important, two different forms of the questions. The statement is find the equation vector form for the following. A part is the line passing through the point with position vector this, so it means this is the position vector, so this will be A, and parallel to, so this is the direction vector. So look now, solution. A part is simple, so A part, so this will be the position vector. A is equal to 1 1 and 1, and B is the direction vector, that is 2 -1 and -2. So the vector equation of the line is R is equal to A plus lambda B. So putting values into the equation, so 1 1 1 is the position vector, plus lambda is still there, and B is 2 -1 -2. So this is the vector equation of the line. Whereas in part B, so be careful, this is the other form of the category, that is line. A line passing through a point A 1 2 3 and the point B -1 3 2. So be very careful, this is the second form. So this will be solved in different way. So solution of B part. So the first point that is given will be the position vector. So that is A is 1 2 3, whereas B will be equal to AB, and that will be equal to OB minus OA, and A is equal to OA. Okay. Okay, now putting values here, OB is -1 3 2 and OA is 1 2 3. So first we will solve these values. So -1 -1 will be -2, 3 -2 will be 1, and 2 -3 will be -1. So this is B vector, and now we are able to put the values into the formula. So R is equal to A plus lambda B. So this is the vector equation of the line. So putting values into it, A is 1 2 3 plus lambda is still there, and B vector is -2 1 -1. So this is the vector equation of the line. The next thing that we are going to do in the topic of vectors is to prove that a point is lying on a line. So a point on a line. The concept is to show that a point lie on a line. We verify that we obtain the same value when equating the position vector of the point with the line. So here is a question. Show that the point with the position vector is this and the line is here. So actually we will equate the position vector of the point with the line. So the position vector of the line is 5 plus 2 lambda . minus lambda j, then 2 plus 2 lambda k. So these are position vectors of the line. Now we are going to equate it with the point. So look now, I plus 3j minus 2k, and now we are going to equate. So I component will be compared with I, so 5 plus 2 lambda is equal to 1. J component is 1 minus lambda is equal to 3, and k component is 2 plus 2 lambda is equal to minus 2. So here we will check either the lambda is having the same value for all these three components. If this is proved, then the point will lie on the line, otherwise not. So look now from here, this 5 will go to the right hand side, minus 4. So lambda will be equal to minus 2. From here, lambda will be equal to minus 2. And from here, this 2 will go to the right hand side, it will make minus 4. Minus 4 divided by 2 will be minus 2. So it is clearly seen that lambda is having the same value for equating all the position vectors of the line and the point. So that's why it is proved that point is lying on the line. So point is lying on the line. The next thing that we are going to read in the topic of vectors is the pair of lines. And in pair of lines, the further thing that we are going to read is the parallel lines. So remember, two lines L1 and L2 with their respective direction vectors B1 and B2 are said to be parallel if B1 is equal to k times of B2, where k is a scalar. So here is a question that will make your concepts more clear. So look now, show that the lines, here is L1, 102 plus t times of 3 minus 1, 4, and L2 is 213 plus s times of 6 minus 2, 8 are parallel. So we are required to prove these two lines are parallel. So look now, solution is here. So for L1, the position vector is 3 minus 1, 4. And for L2, the position vector B2 is 6 minus 2, 8. So these are the position vectors of two lines. And if you can see from here, it is clearly seen that B2 is equal to 2 times of B1. So because if we multiply this direction vector with 2, it will become B2. So look now, 2 3s are 6, 2 minus 1s are minus 2, and 2 4s are 8. So it means B2 is equal to 2 times of B1. So it is proved that one direction vector is k times of the other direction vector. So the lines are parallel. So L1 and L2 are parallel. The next thing that we are going to read in vectors, the topic is pair of lines, and the topic which we are going to read now, the intersection of the two lines. So concentrate yourself, two lines intersect at a point, otherwise they are skewed. And here is a question, find the point of the intersection of the lines. So here are two lines given, that is I plus k plus lambda, I minus 2j minus 3k, and second line is 3i minus 5k plus mu, minus I plus 3j plus 3k. Okay, the method will be, first we will equate the position vectors of two lines. So we will obtain 3 equations. So out of 3, we will use any 2 of the equations to find the value of the mu and lambda. And then these values of the lambda and mu will be put in the third equation. If the equation satisfies, then these lines will intersect at one point. Otherwise, they will be skewed. So look now, the method will be, first we are going to compare the position vectors. So in first line, 1 plus lambda. The second is j is 0. So 0 minus 2 lambda. And the third one is k, that is 1, and here is minus 3 lambda. Okay, the respective position vectors in the second line will be 3 minus mu, then j is 0, so 0 plus 3 mu, and then k minus 5 plus 3 mu. So actually these are 3 equations. So now we will use any 2 of the equations to find the value of the mu and lambda. So look now, from equation number 2, okay, if we give them the order 3 times of equation 1 plus equation 2, so that will be much easier. So look now, 3 times of equation 1, 3 plus 3 lambda will be equal to 9 minus 3 mu. And equation number 2 is minus 2 lambda is equal to 3 mu. So these 2 equations are going to be added. So this factor will be cancelled, and from here 3 plus lambda will be equal to 9, and lambda will be equal to 6. So this is the value of the lambda. Okay, put this value of lambda in equation number 1. So put in 1. So lambda is 6, so 6 plus 1, 7. So 3 minus 7 will be equal to mu. And mu will be equal to minus 4. So this is the value of the mu. So we have used equation number 1 and 2 to find the value of the lambda and mu. So now we are going to put these values of lambda and mu into equation number 3. If this satisfies, then the equation will have a point of intersection. So look now, putting values of lambda and mu in 3. So lambda is 6, so 1 minus 18. And on the right hand side, mu is minus 4. So minus 5 minus 12. So from here you can see this is satisfied. So it means equation will have 2 lines will intersect. Okay, and the point of the 2 lines will intersect, and now the point of intersection can be obtained by putting lambda or mu in either of these position vectors. You may put lambda over here, the same point will be obtained, or you may put mu in these position vectors, so the same point will be obtained. It will be up to you. So look now, we are going to put lambda, so 1 plus 6 will be 7. So 1 plus lambda minus 2 lambda and 1 minus 3 lambda is equal to, so lambda is 6, so 6 plus 1 7 minus 12 and 3 6 are 18, so minus 17. So this is the point of intersection. You may see if we put minus 4 here, the same point will be obtained. So minus 4, so 3 plus 4 will be 7. 4 3s are minus 12 and then minus 12 plus minus 12 minus 5 will be minus 17. So same point will be obtained if you put mu or lambda. So this is the point of intersection. So the next time, so the next thing that we are going to read in the topic of vectors in the pair of lines is skew lines. When two lines do not intersect, they are called skew lines. So the method will be almost same as we have used in the previous question. So first we will compare the position vectors of the two lines. 3 equations will be used. Out of 3 equations, we will use any 2 of the equations to find the value of the lambda and mu. Then putting those values of the lambda and mu will be put in the third equation. If the left hand side satisfies the right hand side, then the two lines will intersect. Otherwise, they will be skew lines. So look now. Here is the solution. So the position vector for the first line is 1 minus lambda, j 0. So that's why 0 plus 3 lambda. And k is 1, so 1 plus 3 lambda. So these are the position vectors of first line, which are going to be equated with the position vector of the second line. So 2 plus mu, then j, that is 3 minus mu, and then k is 0, so 0 plus mu. So these are 3 equations. Now we will use any 2 of them to find the value of lambda and mu. So look now, if we simply add equation number 1 and 2, mu will be cancelled, and look now, mu will be cancelled, and 1 plus 2 lambda will be equal to 5, and from here lambda will be equal to 4 by 2, so 2. This is the value of the lambda. Putting value of the lambda in 1 or 2, it will be up to you. The equation which you seems easy, so put these values in those equation. So look now, lambda is 2, put it in 1. So 1 minus 2 will be minus 1. This 2 will come to the left hand side, so mu will be minus 3. So these are the values of lambda and mu. Now putting these values of lambda and mu in equation number 3. So here is equation number 3. Lambda is 2, so 1 plus 6 equal to mu is minus 3, so it will become plus 3. So because 7 is not equal to 3, the lines do not intersect, so the lines are skewed. Here is another question. The statement is the lines with their respective vector equations are is equal to ai plus j plus k plus lambda 3i minus 2j plus k, and this is the second line, intersect. So the difference in this question and the previous question is it is given in the question that the lines intersect. Now the requirement is find the value of a. Here is a, and the position vector of the point of the intersection. So look now, again we will equate the position vector of the two lines. So look now, so it is given that the two lines intersect anyways, equating. So A plus 3 lambda will be equal to minus 2 plus 2 mu. Okay, then J I minus 2 lambda. So, sorry, 1 minus 2 lambda will be equal to 3 plus 3 mu. And finally 1 plus lambda will be equal to, there is no case, so 0 minus mu. So actually these are three equations. So now we will use equation number 2 and 3 to find the value of the lambda and mu. So look now, 2 plus 2 times of 3. So actually this is the order. So 1 minus 2 lambda is equal to 3 plus 3 mu, and 3 is 2 times, so 2 plus 2 lambda is equal to minus 2 mu. So these are two going to be added, so this factor will be cancelled. So 3 will be equal to 3 plus mu, and from here mu will be equal to 0. So this is the value of mu. Putting this value into 3, so lambda will be equal to minus 1. So this is the value of the lambda. Okay, now the requirement is find the value of A. Now putting these values of lambda and mu in 1. So lambda is minus 1, so A minus 3 will be equal to mu is 0, so minus 2 will be there on the right hand side, so A will be equal to 1. So this is the value of A, which is done at the point of the intersection. So now putting lambda and mu in any one side, so either left side or right side. So look now, if we put mu on the right hand side, so it will be a point of intersection. Will be, so minus 2, 3 and 0. So this is the point of intersection. In other words, minus 2i plus 3j. So this is the position vector of the point of intersection.